So let's go over one of the more common types of problems on the ACT where you're simply having to solve for x. And a lot of times these can throw students off simply because they have this guy where you have an x squared in it. What you want to do is you always want to think anytime you have an x squared or any variable squared in an equation on the ACT, your first thing that you should think of is I'm probably going to have to factor. So what I want to do if I'm factoring is I want to get all of my numbers and all of my variables on one side, and I want to get a 0 on the other. So the first step for this problem is I'm going to add an x squared to both sides. And that's going to give me x squared plus 4x plus 3 equals 0. Now that I have all of my numbers and variables on one side and 0 on the other, I can start to factor. So it's important to remember that this number over here, you want to find the factors for it. So you want to find two numbers that multiply to give you, in this case, positive 3. So for that, it's pretty easy because it's just 3 and 1. And then those numbers have to add up to this number over here. And in this case, it's really easy because 3 and 1 adds up to 4. So how I write it next, I just put x plus 3, x plus 1 equals 0. And now at this step, I'm thinking, okay, well, I have two overall numbers that are going to multiply together to give me 0. So either this guy has to be 0 or this guy has to be 0. So I'm going to set them both equal to 0 and solve. So x plus 3 equals 0, or x plus 1 equals 0. So let's solve this one first. I want to get x by itself, so I'm just going to subtract 3 from both sides. I'm going to get x equals negative 3. On this one, I'm subtracting 1 from both sides. I get x equals negative 1. So my answer is going to be x equals negative 3 or x equals negative 1. So let's take a look at this problem where it says simplify the following expression. A lot of students look at these and they say, I forget the rule for this one. I can't remember. Do I divide or do I subtract? Like, what am I supposed to do? So the first thing that we have to look at are the coefficients, which means these numbers out front, this 15 and this 3. So for these, you can just do simple division for them. So 15 divided by 3, that gives me 5. So I'm just going to write down a 5 on top there. And then when you have x to the 6 and then x to the third on bottom, what you want to do is you want to subtract the exponents, okay? Because this x to the 6 and x to the third, that's really like having 6 x's over here. 1, 2, 3, 4, 5, 6. And then on bottom, it'd be like having 3 x's. And as you can imagine, you're just going to cancel them. And you're going to be left with 3 on top, which would be like x to the third. So I'm just going to write that, x to the third on top. And then y squared over y to the fourth. And now you might be saying, oh, so 2 minus 4, that's going to give me negative 2. Which is perfect because y to the negative 2 is the same thing as 1 over y squared. And if you want to look at it this way again, we can just say, okay, 2y's on top, 4y's on bottom. These guys cancel, and you're left with y squared on bottom. So just write this all over y squared, and we're done. So let's take a look at a problem type that gives most students a little bit of trouble. So it says, given the following equations, solve for f of g of 3. Or some students would read it f of g at 3, either way. So this gives a lot of students problems because they are unsure of where to even start. So first little side note is that when you see f of x or g of x, really what it is saying, this f of x piece right here, so f of x, this is the same thing as essentially saying y. It's just a little bit more detailed because if I put f of, say, 5, this is the same thing of saying y when I plug in 5 for x. So don't be intimidated by seeing f of x, because it's really the same thing of y. It actually even gives you a little bit more detail. F of x is simply saying y, and you're going to put just the normal x in. F of, and if it gives you a number here, you're just going to put that number in wherever you see an x. So for this one up here, it says f of g at 3, or f of g of 3. And you want to work inside out, okay? So what you want to do is you have g of 3. So we're going to be looking at this g of x equation, and I'm going to write g of 3 equals, and then instead of putting an x there, I'm just going to put in a 3. So 3 plus 3. So then I'm going to have g of 3 equals 6. So if g of 3 equals 6, and g of 3 is right here, I can just put a 6 in. So then I'm solving for f of 6. So then I have this equation right here that I'm going to be plugging that 6 into. And because I have x squared plus 7, I'm plugging this 6 into this x. So I'm going to do it in parentheses, 6 squared plus 7. Technically, when I'm adding here, I should have put this in parentheses simply because I was inserting it into the x. Okay, back down to this one. So I have 6 squared plus 7. So 6 squared, that's going to give me 36. And then 36 plus 7, that is going to give me 43. And then I'm done. So this f of 6 is the same thing as f of g of 3. Simply because g of 3, we said, is the same thing as 6. And so this is the same thing. So this would be your answer. Okay, let's take a look at this problem right here. It involves a little bit of geometry. So it says, what is the arc length of x? And it gives you this little circle right here, and it gives you the radius equals 24, and it gives you this little degree measure, which is 60. So a lot of students might panic here. They might say, oh, I can't remember the arc length formula. I remember it has something to do with s. I don't remember it. It was from a math class ago, or maybe 2 math classes ago. So it's really important to remember that you don't need the arc length formula to solve this. What you do need is to remember that you can solve a lot of problems on the ACT simply using proportions. Okay? So the first thing I'm going to think is, well, what is arc length? Arc length is going to be the length of this guy right here. And what is that? That is simply a portion of the circumference. Okay? And then I also need to think, okay, well, what is this? This is 60 degrees. That's also just a portion of the whole circle, which is going to be 360 degrees. So knowing that, I can start to set up a proportion to solve this one. So what I could do is I could say x, which is my arc length, is just a portion of the circumference. Okay? So I'm just going to put C down here for circumference. And that should equal, because it's proportional to this degree measure, as this degree measure changes, you're changing the arc length. That should be proportional to this 60 degrees compared to the total degrees in this circle, which is going to be 360. Okay? So now I have 2 variables. So I'm going to actually solve for the circumference so I can get an actual number down here, so then I can solve for x. So for circumference, it's important to remember for area of a circle, just throwing this in there, it's going to be pi r squared. Circumference, you might remember it as 2 pi r. If you're learning this for the ACT, I prefer writing it as pi times the diameter. Simply because pi r squared, 2 pi r, they both have 2's in it, they both have r's, they both have the pi's. Sometimes students mix these two up. I would rather just try to memorize this one. So if my radius is 24, that means my diameter is going to be 48, okay? So what that means is I'm going to put x over 48 pi. Because what I did is I put a 48 in for my diameter, and then I just leave this pi here, okay? And that is going to be equal to 60 over 360. So just a quick review. I did the part of the circumference compared to the total circumference, that's this guy over here. Set that equal to the part of the angle for my whole circle compared to the total angles, okay? And so now we have, a lot of people just say cross multiply. You can solve this however you want. You just multiply by 48 pi on this side, cross multiply, whatever. You're gonna get the same answer. So for me, I'm just gonna say, okay, well, 60, I'm gonna cancel those. I'm gonna simplify this side first. So they both have a 0, so I can cancel, and then 6 divided by 36, that's gonna be 1/6. So I'm just gonna say x over 48 pi equals 1/6. I'm gonna multiply both sides by 48 pi. I'll just do that up here. So that's going to give me x equals 48 pi over 6. And then I'm thinking, okay, well, is 48 divisible by 6? Yeah, it is. And I'm just going to say, okay, that's going to give me x equals 8 pi. And this is actually going to be my answer. Quick tip on the ACT, unless you get to the solutions and the solutions are actual numbers or potentially have decimals in it, don't multiply by this pi. A lot of times the answers have pi in it, so you're just going to leave it as is.